Hi guys, welcome to this tutorial on how to convert to hexadecimal, binary, and back. Today what we're going to do is we're going to solve a few conversion problems, about 5 or 6, and then we're going to get into some iGCSE questions involving the same material. So let's go ahead and get started. So again, the focus today is going to be on hexadecimal, and to understand what hexadecimal is, let's look at other types of numbers. So first of all, if we have a decimal number, we've got about 10 possible digits from 0 to 9. And this might be a decimal number, right? 359. And really the way we can understand the value of this number is this digit's going to be 10 to the power of 0. This is going to be 10 to the power of 1. This is going to be 10 to the power of 2. So really we're going to have 3 times 10 to the power of 2 plus 5 times 10 to the power of 1 plus 9 times 10 to the power of 0. So that's going to give us 300 plus 50 plus 9 equals 359. Similarly, if we have binary, we might have a binary value like 1, 0, 1, okay? And we're going to approach this like 2 to the power of 0, 2 to the power of 1, and 2 to the power of 2. And here we're going to have 1 times 2 to the power of 2 plus 0 times 2 to the power of 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. Okay, so that's just going to be 4 plus 1 equals 5. And this one we're just kind of showing how a decimal value works. Here we're just converting from binary to decimal, but this is essentially what that value is. So hexadecimal is pretty much the same. It's just that we have, instead of 2 or 10, we have 16. So if we have a value like 3f, we're going to have 16 to the power of 0 and 16 to the power of 1. And remember, for decimal or for denary, we had 10 possible digits. For binary, we had 2 possible digits. And for hex, we have 16 possible digits, going from 0 to f. F being equivalent to 15 in decimal numbers. So this is just going to be 3 times 16 plus f, which is 15, times 16 to the power of 0, which is just 1. So we get something like 48 plus 15, which equals about 63. Okay. So sorry for writing this kind of diagonally, but this is base 10. This is base 2, or binary. And this one right here is base 16, or hex. Okay. So just as a quick refresher, or if you don't know anything about hex, just to kind of show you how it works. So when hex, remember, we have about 16 digits that we can represent. So these go from, these are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So up until 9, these are the same as our decimal digits that we know. But after that, 10 is going to be A, 11 is going to be B, C is going to be 12, 13 is going to be D, 14 is going to be E, and 15 is going to be F. So for example, if we have D in hexadecimal, in binary that's just equal to 13. If we have AD, remember going back to 16 to the power of 0, going back to our bases, that's going to be like, that's got to be a 1 right there. So that's going to be like, so A is 10, so that's going to be 10 times 16 to the power of 1. And D is 13, so that's going to be 13 times 16 to the power of 0. So that's going to be 160 plus 13 equals 173. Okay. So let's go on and do some actual conversion. I mean, I guess we just did a conversion problem, but let's just do another one. So let's say we want to convert 3a to decimal. So this is going to be an example of converting from hex to decimal. Okay. Then what we're going to do is we're going to, first of all, write out 3a, which is going to be our hex number. And we know a equals 10 in decimal. okay? So this is going to be 16 to the power of 0. This is going to be 16 to the power of 1. So we're going to do 3 times 16 to the power of 1, which is a 16, plus 10 times 16 to the power of 0. So effectively 48 plus 10, because 16 to the power of 0 equals 1. And that's going to give us 58. Another example, we're going to use a slightly bigger number. So this one's going to be from hexadecimal again. And we're going to have 2a1. And we want to convert this to decimal. So we're going to have 16 to the power of 0, 16 to the power of 1, and here we're going to have 16 to the power of 2. So 16 to the power of 2 is 256. So what we're going to have is we're going to have 256 times 2 plus a is equal to 10. So we're going to have 16 times 10 plus 1 times 1. Because 16 to the power of 0 is just 1. So this is going to be 512 plus 160 plus 1. And that's going to be equal to 573. Not 53, 573. Okay. Our last conversion example is going to look a little weird, so it's kind of worth going over. So again, this is going to be from hex to decimal. And this one is actually just going to be 33, but in hex. This is something to pay attention to because this looks a lot like a decimal number, but oftentimes in questions, it'll be specified as being a hex number. So you really need to read the question and pay attention. So this looks weird, but it's really not that different, right? So we're just going to have 3 times 16 to the power of 1 plus 3 times 16 to the power of 0. So that's going to give us 48 plus 3 equals 51. Simple enough, right? Well, okay, now what we want to do is we want to go from decimal to hex. So for example, let's say that we have number 121. So we're going to go from decimal to hex. Decimal is also known as denary. So if you ever run into that, then you know that's just the same thing. Denary is written like this and is often used in the iGCSE exam to describe these types of numbers, base 10 numbers. So let's start with a slightly large denary value, 121. Okay. Now there are a couple of ways to approach this. I think that, one way to do it is kind of to do it in the same way as we would convert decimal to binary. So we would just write out like 16 to the power of 0, 16 to the power of 1, 16 to the power of 2. But honestly, like doing that much multiplication kind of makes my head hurt. This is a valid way to do it, where basically we would look for how many 16s can we fit into 121. And I guess the answer would be something like 16 times 7, 16 times 8. Let's see, what is 16 times 8? That's going to be 128. So that's probably too big. 16 times 7 would equal 42 plus 70 equals 112. That would probably work. Yeah, that'd probably work. So we'd put 7 right there. We'd have 121 minus 112 equals, that's going to equal 9. So we just have 7, 9 as our answer for that. I don't know if I did this right, but probably the easier way to do it would be to convert to binary first. So we have 121, and we're just going to convert this to binary. So there's a reason this works, and I'll go through this. But first of all, if we're converting to binary, then we're just going to have, we're going to say 1, 2, 4, 8, 16, 32, 64, 128. Okay. So that means that we're going to start right here with 1. 121 minus 64 is going to be 57. So we're going to have that. So 121 minus 64 is equal to, let's just make sure that's right. Yeah, it's going to be equal to 57. And then we're going to put 1 for 32, so minus 32. That's going to be equal to 25. So we're going to have 1 right there, and then we can have 1 right here. And that means we're just going to have 9 left after that. So we'll have 1 right here, and then 1 right here. So that's going to be our binary value. So once we've done that, then we can divide this up. We can divide, so basically we have the binary value 1, 1, 1, 1, 0, 0, 1. Okay, so we've got this, and it turns out that each hex number is equal to 4 binary numbers. So for example, if we have 1, 1, 1, 1, the maximum number is actually 15, but 4 binary digits, because of the fact that we have 2 times 2 times 2 times 2, is equal to 1 hexadecimal digit. So that just means that whenever we have a number like this, we can just divide this into groups of 4 digits to get our hexadecimal values. So we've got this binary value. We've got a group of 4 right here. So we've got a group of 4 right here. Actually, let me just change the color right there. That should probably make it a bit easier. So you've got a group of 4 right here. And right here, we only have 3 digits. We've got 1, 1, 1, so we can just add 0, so we get 4. It doesn't really change anything, but it makes things more readable. And then once we divided it into these groups of 4, we can just add them up into, or we can convert them to decimal numbers in their groups. So for example, this right here would just be 9 in decimal. And this right here would just be, let's see, it's going to be 1 plus 2 plus 4. So it's just going to be 7 in decimal, okay? So that means that we're going to get 79 again. And 121 in decimal equals 79 in hex. Okay, let's do a slightly bigger example just to give some, just to show you how to do it. Okay, so what we're going to do right here is we're going to convert, we're going to do another example of decimal to, we don't want that one right there, decimal to hex. And what we're going to do is we're going to convert 351. This is going to be a bit messy, but whatever, let's just do it. So we're going to start with 256, 128, 64. I mean, the first thing you want to do is you want to convert to binary, because there's no way that we're going to be able to do the math and just like figure this out with hexadecimal. At least I'm not good enough for mental math. So we're converting to binary first. So we got 64, 32, 16, 8, 4, 2, 1. So the biggest one of these numbers that can fit into, well, we can just write 512 right here. The biggest one that can fit into 351 is 256. So 351 minus 256 is going to be equal to, it's going to be equal to something like 95. No, that doesn't make sense. Yeah, actually that makes sense. 95. Okay. And then, so that means we're going to have a 0 right here. And 64 fits into 95, so we'll do minus 64 equals, that's going to be 31. So we're going to put another 0 here because 32 is bigger than 31. And then we're going to have 1, so we're going to do minus 16 equals 15. And then we're going to have 1 equals 7, then 1, 1, 1. So this is our this is our binary value. So what we can do now is we can divide this into groups of 4. So let's write this out right here. We've got 1, 0, 1, 0, and then 5 ones. 1, 1, 1, 1, 1. Okay, this is our first group of 4. This is our second group of 4. And we have an additional digit right here, and that's just going to be like this. So we're going to, in each of these groups, we're going to convert them to decimal. So this one's just going to be 1. This one is going to be, let's see, that's 1, and that's 4 right there. So this is going to be 5. And this one right here, so this is going to be, well, this is going to be 15 because we have 1, 2, 4, 8. So it's going to be 15. And which in hex is just F. So that means that 351 in hex is just going to be 15F. So for a lot of these problems where we're converting from decimal to hex, what we really want to do is convert to binary first and then convert to hexadecimal. So what we're going to do now is we're going to move on to trying to solve some iGCSE questions. Okay, let's go ahead and let's solve some iGCSE questions. So right here we've got a question that says the hexadecimal color code 43B7F0 is stored in 3 8-bit registers. Give the 8-bit binary values for each of the hexadecimal code. So right here we've got a great example of a question in which we need to convert from hex to binary. So we've converted between hex and decimal and hex. Now we're just going to do some straight hex to binary conversions. So this is actually going to be more straightforward. So for example, right here we've got the hex value 43. So what we need to do is we need to figure out what 3 is in binary and what 4 is in binary. And that's going to be 0, 0, 1, 1, and that's going to be 0, 1, 0, 0. So our 8-bit value for this one is just going to be this. And then 0, 0, 1, 1. Next we've got B7, and B is just 11 in binary, and then we've got 7. So 7 in binary is going to end up being, that's probably going to be something like 1, 1, 1. And then B being 11 is going to be like 1, it's not going to be this one, that's going to be B right there. That's going to be 11 in binary. Yeah, 8 plus 2 plus 1. And then we've got F0. So 0 is just going to be simple. That's just going to be 0, 0, 0, 0. And then F is 15 in decimal. So in binary, that's the maximum number we can have in a 4-bit or 4-digit binary number. So it's going to be 1, 1, 1, 1. So really, we're just taking the digits in a hexadecimal number, and we're just finding the binary value, the 4-bit binary value of each individual digit. All right. Okay. Here's another question. We've got a binary digit, and we need to convert this to hexadecimal. A register in a computer contains binary digits. The contents of the register represent a binary integer. Convert the binary integer to hexadecimal. So again, what we can do is we can just divide this into groups of 4 binary digits. And 1010 is going to be, that's going to be like 8. 8 plus 2 equals 10. And 10 in hex is just A, right? And this one is going to be 3. So 2, 1, that's just going to be 3. In decimal, which is going to be the same in hex. So our answer is going to be 3A. So the value of this one was 10. The value of this one was 3. 10 is hex, or 10 is A in hex. And we put both of them together and we get 3A. All right, and another question. The memory of a computer contains data instructions in binary. The following instruction is stored in a location of the memory. Convert the instruction into decimal. So this is another problem where we're converting from binary to hex. All right. So this is actually this seems like it'd be really difficult because there's a really long binary number. But what we really just need to do is, again, divide this into groups of 4 and then find the hex value, find the decimal value and then the hex value of each 4-digit group. So right here, for example, we've got, this is going to be 8 and 4, which is 12. 8 plus 4 equals 12. And 12 in hex is just going to be B. So we've got B right there. 1, 1, 1, 1 is just going to be 15. So it's going to be 8 plus 4 plus 2 plus 1 equals 15. And 15 in hex is just F. Okay. And right here we have 8 and we've got 1, which is 9. And that's just going to be 9 in hex. It's going to be the same as decimal. Right here we just got 2. And that's pretty much it. So that's just going to be 2. So our answer is going to be 2, 9, F, B. And we've got, I think, one last question right here. The display screen shows a hexadecimal error code. The error code means the water will not empty out of the washing machine. So this is for a program that's operating a digital washing machine. Convert the error code to binary. So as we've always done, we're going to find the binary value for each digit. So this is going to be an example of converting from hex to binary. So we're going to have E0, 4. So 4 is just going to be, that's just going to be 0, 1, 0, 0 in binary. 0 is just going to be 0, 0, 0, 0. And E is going to be 14, which means that's going to be something like 1, 1, that gives us 12, 1, 0. So 8 plus 4 plus 8 plus 4 plus 2. Okay, that works. So that means that our error code is just going to be 1, 1, 1, 0 for E, 0, 0, 0, 0 for 0, and then 0, 1, 0, 0 for 4. Statewide hexadecimal is used to display the error code. This is probably just because it's shorter and it is easier to read than binary. Like if I saw E04, I could probably identify that in a manual. But if I saw 1, 1, 1, 0, 0, 0, 0, 0, let me just make sure that is 0, 0, 1, 0, 0, I think it would just be really hard for me to identify that in a manual. So just easier to read, basically. And that's about it. I hope this has been useful to you. Have a nice day.